The topic we are doing today is tessellation. With tessellations, there are three very important things that you must know about them. First off, the pattern that you're trying to make must have no gaps or overlaps and must cover an entire plane. Second off, when creating the pattern, the angles at each vertex must equal 360 degrees. And lastly, the three figures that make a regular tessellation are a square, equilateral triangle, and a regular hexagon. These figures that make a regular tessellation are known as pure.
To start off, we're going to show you rule number 1, a basic pattern that has no gaps or overlaps and also covers a plane.
Okay, to start off, we're going to show you a basic tessellation with a square. So as you can see, each time I add on a new square, by the way, the shaded square is the original. Each time we add on a new square to the original, you can see that there's a clear pattern and there's no gaps or overlaps, and it's covering an entire plane. Alright, next we're going to show you a more complex shape that can also tessellate. So as you can see, this shape fits perfectly with the other one and makes a clear pattern that fits perfectly. Again, the original shape is the shaded version, and it doesn't matter how complex the shape is. The only thing that matters is the three rules that we told you previously. And there you go.
Next, we're going to move on to the second rule. The angles at each vertex must equal 360 degrees. This is our triangle that we have here. We have a triangle with 65 degrees, 85 degrees, and 30 degrees. We're going to try and turn it into a hexagon and see if it will tessellate and see if each vertex will equal 360 degrees. So I'm going to flip-flop the triangle so that it will make a hexagon. So we're gonna do this, and then we're gonna change the 30 degrees up to here because it flip-flopped, and then the 85 will be down here, and the 65 will be here. Then the 65 will be right here. The 80 would be right here. No, the 85, sorry, would be right there, and the 30 would be right there. And it would be the same for this side. And for all these equaling together, if you add them all up, it will equal 360 degrees, which means, yes, it will tessellate. So I realized I messed up on the angles, but the point is that they add up to 360. So this is supposed to be 30 because of vertical angles, and this is supposed to be 65 because of vertical angles. But these are the same because vertical angles top and down.
Right, before we move on to the next set, you're going to want to know this important equation. 180 times n minus 2 divided by n equals the measurement of one interior angle, and n means the number of sides.
Now we're going to see if the regular pentagon will tessellate. We're going to start off by trying to find this angle right here. And we will also use the equation that Devin previously said, which is 180, 5, because it's substituting n, and that's how many sides this shape has, minus 2, parentheses, divided by 2. And that equals 108. Now, the 108 is this angle, and we will have to see if, and this angle has to be divisible by 360. 360 divided by 108 is not divisible with the whole number. It equals 3 with a repeating 3. So this shape will not tessellate.
Now we're going to be moving on to the final rule, which is that there are three figures that make a regular tessellation, which is the three figures are a square, equilateral triangle, and a regular hexagon. These figures that make a regular tessellation are known as pure. I'm always showing you that the three figures that are known as pure, or figures that make regular tessellations. as you can see, square makes a pretty and balanced tessellation, like so, and an equilateral triangle makes a well-balanced tessellation. I'm sorry if my drawings are kind of bad, and then lastly, a regular hexagon. And that's all you really need to know about tessellations.